Thank you. I'm here with Dr. Ellen Stofan, NASA's Chief Scientist. We're just outside of the Vehicle Assembly Building, and just a few miles away is OSIRIS-REx on the launch pad, ready to head to the asteroid Bennu to collect a sample and then return it back to Earth. Dr. Stofan, what can we learn about studying asteroids that could benefit us in learning about our solar system?
Asteroids are the primitive material left over from when the planets formed. So the Earth, us, this building, everything around us. Asteroids are the key to what were those materials that everything that is around us was made. Now everything on the Earth has been processed, all this material has been processed and processed. Asteroids are the pristine material, and we know they contain really interesting things like the water, that is the water that originated our oceans and all the water here on Earth, and they actually also contain organic molecules that help make us.
And so why did NASA pick Bennu as an asteroid to study, and what are the benefits of a sample return mission?
You know, Bennu is what we call a carbonaceous asteroid. Now, carbonaceous asteroids are the ones where we know they have a lot of water in them, and again, we think that water is the source of the water that's here on Earth, and we know they have organic molecules on them. In fact, some of the letters in our DNA that make up our DNA, those molecules have actually been found in carbonaceous meteorites. So Bennu could hold keys not just to the origin of water on Earth, but to the origin of life on Earth. So we're particularly interested in that type of asteroid. Now, when you send a spacecraft to either a planet or an asteroid, you take along instruments and you do the best job you can of characterizing the material. But you have to realize when we shrink a scientific instrument to fit down onto a spacecraft, it becomes a little less capable. If we can actually bring those rocks back here to Earth, we can analyze them with instruments that fill a room, basically. We get much more precise and better information. So scientists, especially geologists like me, we like to get those rocks back here on Earth where we can do really amazing science with them that we just can't do remotely.
And now NASA's planning to do an asteroid redirect mission and then eventually a journey to Mars. How does this mission help that goal?
You know, because small bodies are potentially really interesting in the future for resources, they're really interesting for water, and of course we're concerned about them from a planetary hazard point of view. Asteroids have hit this planet in the past, and they will hit us again at some point in the future. The asteroid redirect mission tests technologies like solar electric propulsion that we're going to use to get cargo out to astronauts who will someday be out at Mars. We're also going to be testing techniques that will help us understand how we might in the future potentially deflect a hazardous asteroid. So it's helping us protect this planet, and the asteroid redirect mission is going to help us to get us on our way to getting humans to Mars. And OSIRIS-REx is really the first step. It's teaching us how do we get to a small body, how do we maneuver around it, how do we get a sample back. It's the first step. The asteroid redirect mission is the next step.
Excellent. Well, thank you for being with us today. And back to you.